equations reducible to a pair of linear equations in two variables. In this module, we shall discuss the solution of such pairs of equations which are not linear but can be reduced to linear form by making some suitable substitution. Let us explain this process through some examples. Let us discuss the first type. Solve the pair of equations. 1 upon 2x plus 1 upon 3y is equal to 2 and 1 upon 3x plus 1 upon 2y is equal to 13 upon 6. Let us write the given pair of equations as 1 upon 2 into 1 upon x plus 1 upon 3 into 1 upon y is equal to 2. This is equation 1. 1 upon 3 into 1 upon x plus 1 upon 2 into 1 upon y is equal to 13 upon 6. This is equation 2. These equations are not in the form ax plus by plus c is equal to 0. However, if we substitute 1 upon x equal to p and 1 upon y equal to q in equations 1 and 2, we get 1 upon 2 into p plus 1 upon 3 into q is equal to 2. After taking LCM of denominators, we get 3p plus 2q upon 6 is equal to 2. Which implies 3p plus 2q is equal to 12. This is now equation 3. Similarly, the other equation can be written as 1 upon 3 into p plus 1 upon 2 into q equal to 13 upon 6. After taking LCM of denominators, we get 2p plus 3q upon 6 is equal to 13 upon 6. Which implies that the second equation becomes 2p plus 3q is equal to 13. This is now equation 4. So, we have expressed the equations as a pair of linear equations. Now, we get p is equal to 2, q is equal to 3 by solving equations 3 and 4. But we know that p is equal to 1 upon x and q is equal to 1 upon y. Substituting the values of p and q and solving, we get 1 upon x is equal to 2. This implies x is equal to 1 upon 2. And 1 upon y is equal to 3. This implies that y is equal to 1 upon 3. So the solution of the given system of equations 1 and 2 is 1 upon 2, 1 upon 3. Now let us take type 2. Solve the pair of equations 2 upon under root x plus 3 upon under root y is equal to 2 and 4 upon under root x minus 9 upon under root y is equal to minus 1. Let us write the given pair of equations as 2 into 1 upon under root x plus 3 into 1 upon under root y is equal to 2. This is equation 1. 4 into 1 upon under root x minus 9 into 1 upon under root y is equal to minus 1. This is equation 2. These equations are not in the form ax plus by plus c is equal to 0. However, if we substitute 1 upon under root x equal to p and 1 upon under root y equal to q in equations 1 and 2, we get 2p plus 3q is equal to 2. This is now equation 3. 4p minus 9q is equal to minus 1. This is now equation 4. So, we have expressed the equations as a pair of linear equations. Now, we get P is equal to 1 upon 2. Q is equal to 1 upon 3 by solving equations 3 and 4. We know that P is equal to 1 upon under root x and Q is equal to 1 upon under root y. Substituting the values of P and Q and solving, we get 1 upon under root x is equal to 1 upon 2, which implies x is equal to 4, and 1 upon under root y is equal to 1 upon 3, which implies y is equal to 9. So, the solution of the given system of equations 1 and 2 is 4, 9. Now, the turn of type 3. Solve the following pair of equations by reducing them to a pair of linear equations. 10 upon x plus y plus 2 upon x minus y is equal to 4. 15 upon x plus y plus 5 upon x minus y is equal to minus 2. Let us write the given pair of equations as 10 into 1 upon x plus y plus 2 into 1 upon x minus y is equal to 4. This is equation 1. 15 into 1 upon x plus y minus 5 into 1 upon x minus y is equal to minus 2. This is equation 2. These equations are not in the form ax plus by plus c is equal to 0. However, if we substitute 1 upon x plus y is equal to p and 1 upon x minus y is equal to q in equations 1 and 2, we get 10p plus 2q is equal to 4. This is now equation 3. 15p minus 5q is equal to minus 2. This is now equation 4. So we have expressed the equations as a pair of linear equations. Now we get P is equal to 1 upon 5. Q is equal to 1 by solving equations 3 and 4. We know that P is equal to 1 upon x plus y and Q is equal to 1 upon x minus y. Substituting the values of P and Q and solving, we get 1 upon x plus y is equal to 1 upon 5, which implies x plus y is equal to 5. This is now equation 5. And 1 upon x minus y is equal to 1, which implies x minus y is equal to 1. This is now equation 6. Adding equations 5 and 6 we get, which implies 2x is equal to 6, which implies x is equal to 3. Substitute x is equal to 3 in equation 5. 3 plus y is equal to 5. This gives y is equal to 5 minus 3 is equal to 2. So, the solution of the given system of equations 1 and 2 is 3, 2.